Hello everyone, welcome to my channel. So we have discussed core module of DMAT in last 5 videos, DMAT class 1, 2, 3 and 5. Now we are discussing journal academic module of official PDF. So before we dive into this particular topic, we are going to learn about the journal instructions that they have given in the official PDF. In this task type, you see a text, number of questions which you have to answer. There are 4 answer options for each question. So basically you are going to get MCQ question type. For each question there is only one correct option. The text, they can give you text, the questions and the answer option may contain figures, tables, formulas. For working on the entire subject test in the exam, you have 90 minutes in total. If you do not know an answer, please guess the answer might be correct. You are not allowed to take notes in the exam. Basically, they are telling you that MCQ questions are there. 90 minutes would be there for this journal academic module. And in this journal academic module, or for the practice and illustration of the subject module task, 4 exercises are available here. Basically, what are those 4 exercises that we are going to learn in this video? Firstly, we are going to discuss first exercise only. Please note that the sample question do not necessarily reflect the difficulty level of the questions on the actual test. So they are giving you that instruction that sample questions are the just example or what topics they can ask you questions from, but the difficulty level won't be same. It can be more difficult questions in your exam, or it could be the chance that you can get easiest questions as well. Furthermore, the questions represent only a selection of possible topics that may be covered. Okay, and there would be possible topics would be there, only a selection of possible topics that may be covered. The possible topics of this task in the actual exam cover a variety of ideas. So what could be the topics? Mathematics would be there, computational sciences would be there, natural sciences, engineering, business administration, economics, social sciences and humanities. These are the topics that are going to be covered. So now move with our first exercise here, that is vector calculations. Students who are from engineering background, they have done vectors in class 12th. Even students who are from commerce background, who had taken maths in 12th class, or maybe they had done this vector calculations in BBA maths as well. So that is the same thing here. But I'm going to teach this topic that like this, that you are not familiar with vector, you are doing it for the very first time. So let's start with our topic, vector calculations. Before knowing about what is vector, you should have knowledge what is a scalar. So basically, scalar is just one number. Scalar is just one number. For example, you can say A is equal to 2. You can say about temperature is 25 degrees Celsius. Weight, just a number, that is called a scalar. Then there is a vector. So what does it mean by vector? Vector first represent a size, a magnitude, Second, a direction. For example, walk 5 meters east. They are giving you first magnitude plus direction. That is called vector. So that would be represented by this arrow sign. A scalar is just represented by a alphabet, and a vector is represented by arrow. So now here what they are talking about, while so-called scalar values consist of a single number, for example a equal to 2, vectors are formed from several numbers. Vectors can define a point in n-dimensional vector space using n numbers. These documents will focus on vectors in 2 or 3-dimensional vector spaces, hence consisting of up to 3 components. See figure 1 as an example of 2-dimensional case. So what they are giving you hint that in your exam you are going to get 2D and 3D vectors. 2D means 2-dimensional, 3D means 3-dimensional. Means you can get points like this where 2 alphabets are there, 2 coordinates are there, and you can also get a point where 3 alphabets are there, x, y, z. For those you have to solve vectors. So first of all they are talking about, look at the figure 1 here. So basically here this is a graph. They are giving you a vector here. How we are going to define this vector? First of all, you should have that knowledge. What is the point here? That is 4, 2. 4 units to x axis, 2 unit to y axis. And this is a line segment. A line segment which has a direction and it has a magnitude as well. Magnitude that you have to find. How you will find that I'm going to tell you. What is the length of this particular line segment. Now how you are going to represent this line segment in the form of vector? First of all, it has a direction, it has a particular length, so this is a vector, and you are going to represent it like this. X coordinate, Y coordinate. So what is X coordinate here? That is 4. What is Y coordinate here? That is 2. So vector you are going to represent like this. A vector is 4, 2. Now you have to find the magnitude as well. How you will find the magnitude of the vector? We have this formula, x square plus y square. X square, 4 square plus y square, 2 square, 16 plus 4, that is equal to root 20. Now you would have that problem that we won't be having pen and paper in exam. How we are going to find root 20? But you can approximate the value. You know that what is root 25? That is 5. So what would be root 20? 4 point something. So it would be 4.47 units. So this thing that I have explained to you, what is a scalar? It's just a value. What is a vector? With value, with a direction, how you will find a vector in two-dimensional space, how you will find that magnitude of that vector. That is discussed till now. Now move next. What they are discussing in this paragraph. In this paragraph, when adding two vectors, the individual components are added. This also applies to the subtraction of vectors. When a vector is multiplied by scalar, all its components are multiplied by this scalar. If the scalar is greater than 1, the length of the vector is accordingly extended. If the scalar is greater than 0 but less than 1, the length of the vector is shortened. Now we have to discuss these points. What they are talking about, they are just talking about this. Then when two vectors, okay, you can you can represent vectors like this. You can represent vector like this. It's just your choice. So it's up to you. We can just write it like this. You can represent a vector like this as well. So when you are going to add two vectors, what will happen? It will become 7 plus 4. You have to add this. You have to add like this. And same rule that would be followed with minus. 4, 2, minus 3, 2. That would be equal to 1, 0. And scalar. Scalar means a number. How you will multiply by a number like 2, 4, 2. That would be multiplied like this, 8, 4. Okay. So that is there. And they are giving you another thing. If the scalar is greater than 1, this is a scalar greater than 1, the length of the vector is accordingly extended. Obviously, length of the vector that would be extended when you are going to find the length of the vector. That would be extended, right? That would be bigger. If the scalar means 2, whatever the number that we are multiplying with the vector is in between 0 to 1, for example 0.5. So obviously that length would be shortened. That would be 4 plus 1 root 5. So that has been discussed till now. For vector representation in Cartesian coordinate system, the length of the vector, the magnitude of the vector can be calculated using the Pythagorean theorem, or it is generalization to several components. So they are talking about that how we can find the length of the vector with the use of Pythagorean theorem. Pythagorean theorem means Pythagoras theorem that you already know. You can just take it how you will find this hypotenuse. You know that this is 4, 2. You know that this is 0, 0. You also know that what is this side, this is 4. You know that what is this side, that is 2. And length, how you will find? With AB square plus BC square is equal to AC square. You can also find it like this, or you can just find it like x square plus y square that we have discussed, that they are talking about. Among the most important operations in vector calculation are the scalar product and the vector product. So they are going to ask you mostly the questions from the scalar product, vector product, and vector product is also called cross product. Vector product and cross product are same. Additionally, a so-called triple product has been defined. Third, triple product is also defined, which represent a combination of scalar and vector product. So they can also ask you the question, what triple product represent? It represents the combination of scalar and vector products. The following table provides an overview where the angle psi, or you can say it phi, whatever you can name this sign, describe the angle between the two vectors. So they can give you the formulas in your exam table as well. So this is scalar product, vector product, or this vector product is also called cross product and triple product. Now what does it mean by scalar product? Scalar product means you are going to find the answer when you are going to multiply two vectors. You are going to find answer in a number like a scalar. Vector product, when you are going to cross product two vectors, you are going to find the answer in vector. And there is a triple product that you have to find what would be the answer. So now we are going to, because it represents with dot and cross product, that we have to find what would be the answer. I'm just giving you that hint. Now how can we easily remember all these things? And this is a further relationship how you are going to find that angle between two vectors. What would be the angle between two vectors? That how you will find it. So that we are going to discuss later. Before that, we are going to solve some questions so that you can understand how we are going to use all these formulas. I can give you a quick example for scalar product and the vector product first. For example, if you want to do a scalar product, like you have, they are giving you here 3 dimension, 3 points. Scalar product that you have to do. You have 2 points, 1, 2, 3, and second that is 4, 5, 6. 2 vectors are there, 4, 5, 6. How you are going to multiply these? You are going to multiply it like this: 1 with 4, 2 with 5, 3 with 6. 1 multiply 4 plus 2 multiply 5 plus 3 multiply 6. So that would be 4 plus 10 plus 18, 14 plus 18, that would be 32. So answer is 32. So what they are talking about here, ax, ay, az, this complicated things. Basically this is ax, this is ay, this is az, and this is bx, this is by, bz in simple language, and you can do it this sum in your mind very easily. What they are just going to ask the scalar product, you are just going to multiply in your mind 4 plus 10 plus 18, what would be it? 32. Now how you are going to multiply cross product? How you are going to do a cross product? So cross product, this formula is there. That is a y z, a y b z. You just have to learn yz, zy, opposite zx, xz, xy, yb. So how you are going to solve this? Just a minute here. Okay. First write ax, ay. First you have to write ay, yzx. Okay. Y, z, ax, that is 1. Bz, bx, by. 6, 1, 6, 4, and 5. That you have to multiply. Minus az, by, minus ax, bz, minus 2 ay, bx, that is 4. That would be 12 minus 15 minus 3, 12 minus 6, 6, 5 minus 8 minus 3. So this is not representing basically a simple scalar number like 32. It is representing a vector here. So that I have already told you, cross product will represent a vector here. Now there is a triple product that we are going to solve also in next question. So this is basically the definitions of cross product and dot product and triple product. Now moving that, you have to just remember yz, zy, zx, xz, xy, ybx, and this is the like formula for the angle that you are going to discuss in next questions. And triple product will also result in scalar. Cross product will result in vector. Scalar product will result in scalar. That you have to remember. Now move further. First question. Which vector results when operation S vector is equal to A vector plus B vector minus C vector is performed? So what is, if you have to just solve this question in 75 seconds, how you are going to solve this? What is A vector here? That you have to find first. What is B vector here? That you have to find. What is C vector? A vector is basically this. B vector is this. C vector is this. So C vector is minus x value, that is 0, minus 2. B vector is 5, 0. What is A vector? That is basically 0, 2, 0. Okay. Why it is 2, 0? We know that what is x coordinate and what is y coordinate. Now what we have to do, just a minute, 1 second. Just a minute. Yes. You have to find this point. This point is basically 1, 3. This point is basically 5, 1. And this point is basically 1, minus 2. So we have to add these points. So that would be 1 plus 5 minus 1. Okay. 3 plus 1 minus 2. 6 minus 1, 4 plus 2. Answer would be 5 and 6. So the vector answer is 5, 6. What rule we are performing? That is 1, 3 plus 5, 1 plus 1 minus 2. You have to add first A. Okay, 1 plus 5 minus 1, then 3, second numbers 3 minus 2. So the answer would be 5, 6. Now move to the next question. Question number 2 is, which statement is true when a vector is multiplied by a number minus 2? You can take an example. You can take a vector, for example, vector 2, 1, and you are going to multiply with minus 2. The answer would be minus 4 minus 2. And you can also find, try to find the magnitude as well. If you have to find, okay, they are talking about the length and they are talking about the direction, so you have to find the magnitude as well. When you are going to find the magnitude of this, that would be minus 4 square plus minus 2 square, that is 16 plus 4, that is root 20, that is 4.4 something. And if you are going to find the magnitude of this, that would be 4 plus 1, that is root 5. Root 5 is basically 2 point something. So the length of the vector doubles. Length of the vector doubles, the direction of the vector remains the same. If you are if you can just see this vector like this, a positive vector would be like this direction 2, 1. If the point is like minus 4 and minus 2, that would be in the negative direction, obviously. The length is obviously doubled. Here the length is 2. When we are going to multiply with minus 2, that would be doubled. But the direction of the vector don't remain the same. It would be in the opposite position. So this is wrong. The length of the vector halves, the direction of the vector is reversed. No, it doesn't get half, it get doubled. Reverse, that is okay. That is wrong. The length of the vector doubles, the direction of the vector is reversed. That is correct. The length of the vector halves, the direction of the vector remains the same. That is wrong. So the C option is correct. I have given you an example as well. That you have to just remember this fact. That if we are going to, this fact that you have to remember, if you are going to multiply, by 2, length would be doubled, direction would be same, because it is positive 2, no? It would not change the direction. Minus 2, length is doubled, direction reversed. Any number between 0 to 1, for example 0.5, length positive 0 point, length with half, direction same. If you are going to multiply with minus 0.5, length with half, direction reversed. So it's just you have to keep it in your mind, when you are going to get a negative thing, obviously direction would be changed. And when we are going to multiply with half, length would be halved. When you are going to multiply with double, length would be doubled. Direction would change with minus sign on. Now move further to the third question. The type of the result from the 3 operations presented in the table is not always the same. Which statement is correct? I had already told you one thing very clearly here, again and again. They are going to give you table, figure, helping, material as well. They are giving you here table that 3 types of products are there. What are the result of those products? Scalar product will result in scalar, a number. Vector or cross product will result in vector. triple product will result in scalar. So basically scalar and triple product will answer same, but vector product that would answer in vector. Now they are asking you in the question here that forming a scalar product result in a scalar, that is correct in A option. Forming a vector product result in vector. Forming a triple product result in vector, that is wrong. That I have already told you that a triple product will also result in a scalar. So forming a scalar product scalar, forming a vector product vector, forming a triple product result in a scalar. That is correct. Forming a scalar product result in vector, that is wrong. Forming a scalar product result in vector formula, that is also wrong. So this is the correct answer. I have already told you deeply in the instruction itself. Now move to the question number 4. Question number 4. For the following vectors, the scalar product was calculated. Which result of the calculation is correct? You just have to, easiest question, okay? You just have to find the calculation. What you are going to do in the scalar product? 1 multiply 4, 4, plus 2 multiply 5, 10, plus 18. So basically you are doing this in your mind. You have to do product, that would be 32. Answer is 32. Now move to the next question. Question number 5. With the scalar product, it is possible to determine the angle between two vectors. What angle is formed between the following vectors? Arc cosine is the inverse of function of the cosine. They have already given you this table from where you have to find. Dot product is equal to this. Okay. We are going to write it from the table here. Okay, you have to find the angle. Okay, if this is multiplied here, magnitude, that would be divided here. And arc cosine is the inverse of the, that I am going to tell you. First of all, you have to find this thing. That is 2 plus 2, that is 4. Magnitude of this, that would be equal to 1 square plus 2 square, a vector, that is root 5, and this is also root 5. That is 4 by 5. Okay, so basically cos psi is equal to 4 by 5. And arc cosine is the inverse of the function of cosine. This is, they are talking about arc cosine is inverse function of cosine. What is inverse of cosine? You just have to take cos there. On the right hand side, it will result in inverse function, inverse trigonometric function. So that is, this cos inverse is basically, arc cosine is basically inverse of cosine, that is inverse. So basically the answer is 4 by 5. A option is correct over here. A option is correct. Now move to the next question. Question number 6 here. Which vector results when the vector product of the following vector is determined? They have given you already the table. And you have to find the vector product, cross product. I have already given you that idea, what you have to do. Basically, you can just easily find this vector. You can just write it like this, 3, 2, 1 or 6, 5, 4. Okay. And you can claim it as A1, A2, A3, B1, B2, B3. Or you can write it as AX, BX, whatever, according to the formula as well. Now what you have to do? You just have to start from the bottom, A1, B2 minus A2, B1 and A3 B1 minus A1 B3, A2 B1 B3 minus A3 B2. Okay, start like this, or you can represent it as like this as well: AX, AY, AZ, BX, BY, BZ. Now you have to find it. That is equal to 2 multiply 4 minus 1 multiply 5. And next is 1 multiply 6 minus 3 multiply 4. And next is 3 multiply 5 minus 2 multiply 6. The answer would be 3 minus 6, 3. You don't even have to solve the third component. You are going to just eliminate the other options. Just remember this formula. 1, 2, 3, 1, 2, 3. First you have to go here, then you have to go here, then you have to come here. Now move to the next question. The magnitude of the result vector product, whatever the vector product that you are going to find, you have to find the magnitude of that, correspond to the area of parallelogram spanned. How large is the following area? Note the formula for the three-dimensional case can also be used here if the z coordinate are set to 0. So basically you have to find the area of parallelogram here. So what is basically the area of parallelogram? They have already told you. They are going to give you hint again and again. That is magnitude of cross product. And they have already given you that idea that here you can use, because a cross product you have to you should have that 3 coordinates. This is a 2-dimensional space. They are telling you take z coordinate 0. So what would be this point? Basically this point is 3, 4, take z coordinate 0, and this point is, what is this point? Minus 2, sorry, x coordinate is 1, positive 1, and this is minus 2, and z coordinate 0. So you have to find the cross product, and when you have cross product, when you have the z coordinate 0, it will result into this formula only: ax by minus ay bx. Because whenever you are going to find the z coordinate, whenever you are going to multiply z, that would be 0, 0, 0. So ax by, that only would be the result. Resultant would be there. Result would be there. So ax, that is 3, by, that is minus 2, ay, that is 4, 1. Answer would be 10. And I can give you one 10 square units d. I can give you one more tip here. That is quick shortcut. For 2D vectors, if you have A, B and C, D, if you don't have to take the third coordinate 0, but they have specially mentioned in the question, that's why we have taken 0. But if you just have to find 2D vectors and you have to find the parallelogram area, what you are going to do, you are just going to use this formula AD minus BC. That will also result in 10 square unit here. So we had the coordinate in 2D, that is 3, 4 and minus positive 1 and minus 2. You can easily find the answer from here. that is 3 minus 2 minus 4, 1, that would be 10. So that is 10. So they had told you to find the magnitude of the result vector, and if you are going to you just have to find the magnitude of result vector correspond to the area of parallelogram spanned. That is basically you just have to find the cross product, and when you are going to find the cross product here and you are going to take that magnitude, that would result in 10 square 2 times. That is the answer here. Now this is all about all the questions. There is a question number 8 as well. The triple product can be used to calculate a volume. Vector product is used to find the area of the parallelogram. So that we have found here, this represent basically the you can say a magnitude. This represent like the area won't be negative. If the answer is minus 10, it would be positive 10. You don't have to take it like a root square something that we have done to find the vector length. You don't have to use that formula. Now move to the question number 8. The triple product can be used to calculate a volume, and the cross product that is used to find the area of the parallelogram. That you have already learned in question number 7. Now, the volume pertains to the space in composed by the 6 parallelograms defined by 3 vectors. Which statement is correct for all possible cases when the triple product has the value 0? One thing that you have to remember, that triple product is this, and they are talking about this is 0. The volume they are talking about, volume is 0. Volume is 0 for that particular shape which has 6 parallelograms. Volume is 0 only when basically volume is 0 only when vectors lie in just a minute, give me a minute, just a minute. Yes, So we have this question number 8. The triple product can be used to calculate a volume. The volume pertains to the space encompassed by 6 parallelogram. Volume is 0 only when the vectors lie in a plane. The vectors are pairwise perpendicular. The vectors are linear independent. The vectors sum up to 0 vector. You have 4 options here. And the volume is 0 only when all vectors lie in a same plane. We have like 3 planes x, y and z. If all vectors lie in a same plane, then the volume of that shape, which has basically 6 parallelograms, whatever the shape it is, 6 parallelograms, that would be 0. So you just have to remember one thing in your mind. Whenever vectors lie in a same plane, okay, the volume would be 0. If the vectors are perpendicular, if the vectors are linearly independent, the vectors sum up to 0 vector, all the answers are incorrect. Because when the perpendicular vectors would be there, that would be 1, 0, 0, that would be 0, 1, 0, that would be 0, 0, 1. So the product would be 1. Okay, the volume product would be 1. That won't be equal to 0. Linearly independent, if the triple product is already 0, that vectors are basically linearly dependent. That vectors are not independent. Now move to the next. The vectors sum up to the 0 vector. That is not even required. So this is all about the vector topic that we have discussed till now. What we have discussed, what is scalar, what is vector. Scalar is basically just a number. A vector is a number with a direction. How you are going to represent a scalar just by an alphabet. How you are going to represent a vector with arrow sign. And how you are going to find the magnitude with this formula x square plus y square, or you can find with the Pythagoras theorem. How you are going to add two vectors like this only, 4, 3, 4, 4, and how you are going to subtract like this. They are going to give the questions like this that you can easily solve. Okay, if you are going to multiply with a scalar that is greater than 1, that obviously the magnitude would be also, you can say, magnitude, whatever the magnitude would be, that would be extended. If you are going to multiply within 0 to 1, the magnitude would be shortened. And then they have given you the whole table from where you have to find your answers. Formulas tables is also there. And you have to remember one point. Dot product answer would be scalar, cross product answer would be a vector, and the triple product answer would be scalar. And now moving further, which vector result when the operation this is performed? First of all, try to learn the coordinates. Don't get confused that this is starting from 0 or anything. You have to find this coordinate 1, 3, 5, 1, 1 minus 2. Then you have to solve. You will get these 3 points here. Solve and you are going to find the answer. Question number 2, which statement is true when a vector is multiplied by minus 2? That I have already told you. When you are going to multiply a vector with a minus thing, the direction would be reversed and the magnitude would be doubled. The type of the result from 3 operations presented in the table is not always the same. Which statement is correct? Okay, so you know that the scalar product result in scalar, forming a vector product result in vector, forming a triple product result in vector. That I have already told you in the summary only. You have to find the scalar product that you can easily do it in your mind. You have to multiply this with this, this with this, and this with this, and add all of these. Answer would be 32. And with the scalar product, it is possible to determine the angle. You have already given the angle in the formula table. You just have to take it as it is, and then you know that the answer is 4 by 5. Okay, and what is this? With this cos, with this sign, whatever sign it is, phi, you are going to take this cos on the right hand side, that is represented arc, cosine is represented by inverse. Now you have this question number 6, vector product that you have to find, that I have already told you the formula. Now next question number 7, area of the parallelogram. I have given you an idea that you have to just do the cross product here, and after the cross product, whatever the answer is there, that you have to take with answer and write square units with that. Now move to the question number 8. When the volume is 0, all the vectors lie in a plane. They are coplanar as well as they are linearly dependent. These 8 questions and the whole summary of the vector is discussed here. We are also giving one-on-one classes for the core module, for the DMAT actually, the whole DMAT. You can also comment below if you need any one-on-one classes. Batches are there. Thank you so much for watching this video. Like and subscribe for the upcoming videos as well. Thank you. Thank you so much.